Hello everyone, how are you doing? I'm Varun Srivastav and today we will talk about sorting algorithms. Sorting algorithm is a very important branch in computer science. Basically, it increases the efficiency of other algorithms. So there are many algorithms out there which won't work efficiently if sorting algorithm is not applied to them. And sorting algorithms is used in a wide array of applications. Like suppose if you have to sort the person by name or sort the person by age, then these algorithms will come very handy. So in today's tutorial, I'm going to talk about multiple sorting algorithms from elementary to advanced. So we'll start with the bubble sort, then we'll move up the ladder and go to selection sort, insertion sort, then merge sort, and finally the quick sort. And each of these algorithms have different time complexity, and we'll take a look which algorithm is suited for which type of application. So in a nutshell, a sorting algorithm is any algorithm that puts the element of a list in certain order. It could be ascending or it could be descending. And there are different types of sorting algorithms, and we are going to talk a small subset of those algorithms that will help us to learn something more, something bigger concepts in to grasp bigger concept in computer science. So the first algorithm that we will talk about and code as well will implement every sorting algorithm. So the first we'll start with bubble sort. Bubble sort is the oldest algorithm. It is basically a comparison based algorithm in which each and every element of the array is compared with each and every other element of the array. So this is just for the learning purpose. We don't use it in practical applications, and it is not even recommended because the time complexity is very high, is squared of the input, so not at all feasible. Then we'll move on to learn selection sort, insertion sort, shell sort, merge sort, and finally we'll end it with quick sort. And then we'll create a comparison program which will the compare the time complexity of each of these algorithms. So we will run each of these algorithm against a set of inputs, like in numbers of order of 10 to the power 6 or 7. We'll give them a lot of input, a big input, and see how much time it takes to actually sort that array. So we are going to do all this in this tutorial series. So let's see what a bubble sort actually is. So by the way, I created this Instagram page where I share my bits and pieces on programming and other stuff. So recently I posted on bubble sort, and that is why I'm also creating this video. So as you can see, the bubble sort is a very simple sorting algorithm, and it repeatedly steps through the list, compares the adjacent elements, and swap them. Simple, very easy. So let's see how it works. So this is the first pass. Suppose you have the array as 4 3 1 2 5. So in the first pass it will only swap 3 and 4. In the second pass it will swap 1 and 4, and likewise it will keep on swapping till the size of the input squared, and at the end we will have a sorted array. So this is how bubble sort works, and this is what we are going to implement it now. So let's go back to our IDE, and if you have seen my previous video, we always create one package and we always name it code with Varun. And inside this package we will create one class called bubble sort, and this time I'm going to write test first. We are going to do TDD development because in the previous video we didn't do that, and some of the folks were not happy with that, and I don't want to make them sad this time. So I'll start with a test case of the class which we are going to write. Okay, so it basically we are writing a sorting algorithm, so it will have only one method and it will do only one thing. So we can create a class, we can create a test case and name it like it should sort the given array in ascending order, and we'll create a class bubble sort, new bubble sort. So the one thing that you get with TDD is that most of the job is done by your ID. For example, I just passed the test array inside, and I'll ask my ID to create this object. This is an integer array, and I'll pass the array here. Let's say 23042886. So this is a test array, and we're passing the test array to this class. If you are hearing any noise, it is because it is raining outside and it's pretty awesome. Yeah. Okay, so coming back, so we'll create a constructor. Again, id is doing everything for me if you see this. So I'll just assign this dot input to input, and I'll ask my id again to create this field for me. So it is very easy with DDD. Most of the job is done by your id. Then we'll call the sort method inside our bubble sort class. This method, it will basically sort the sort the given test array. And how can we assert like if the array has been sorted or not? So for that we will have to iterate over the array. So we do that with range method. We will start with the 0th index and we'll go till the length of the array, and then for each index we will assert that the index 1 should always be less than index plus 1. In ascending order, like 0th index is always smaller than the first index, and then first index is always smaller than the second index, and that is what we are asserting here. So we can replace it with lambda. It is more crisp. One thing is that if it will reach at the end of the array, then this will be the length, and it will check for 1 plus, which will overflow our array and will get the exception array index out of bounds. So we don't want that, so we'll limit it to -1. That way it won't reach till beyond the end of the array. Now we'll implement the sort method. Now here we have a choice. We can do it with Java 7 or Java 8 or Java 11 or Java 13 or Java 14. Since we are living in an era where we have Java 14, so we'll at least do this with Java 11. So we'll do the same thing. Like we'll iterate over, start with range. We'll go till the length of the array. Then for each outer index, we'll iterate the inner loop n times. That is why it has the complexity of n square, and we really don't support this bubble sort in our production environment. Then we will iterate it till the length of the array for each inner index. Now we have to compare and see, like if input dot inner index plus 1 is smaller than the inner index, then we have to swap. We know that. So for that we will take a temporary variable swap, and we'll provide it the value of the current index. Then in place of current index, we will put the value which is there in index plus 1, and then at the end we will put the temporary variable over index plus 1, and this will swap our array. Let's make it one liner. We don't need that bracket. Yeah, let's make it more crisp. And also we can take this method out into a swap method, more crisp. Then we can do it like this. So everything is in one line. Cool, huh? Awesome. Okay, so this should sort our array. Let's test this, and it should work. Please work. Okay, it never works for me for the first time. Okay, it is saying index out of bound here. Index plus 1. Oh, it is the same thing. So we'll have to limit it to -1 so that it doesn't overflow. This is what I was talking about. So let's go back to our test class, run it again. This time it has sorted the array, and this is how bubble sort works. So if you have any question, do comment below. Otherwise, we'll move on to the next sorting algorithm, which is selection sort. Bye bye.